my stream? Oh, okay. Okay, it seems like it's working. I'm gonna share it maybe. Okay, so last time we left off with this memory thing, and our clock is not working, so we're gonna need to rebuild it. And now I got a new component that we need, so that we can build it again. And maybe we're gonna rebuild this entire thing, because I also got a wire. Yeah. So I got this stripper wire thingy. I'm gonna switch. Yeah, stripper wire. Wire stripper, not stripper wire. So we can easily cut off the wire, and I got this hookup wire, a bunch of it. So that's great. I also bought some SRAM, which we're going to build a memory resistor and then start to build a thread along the way. And I also got some breadboard. Okay, okay. So I got this smaller version of the breadboard, because we're going to build clock and it doesn't need much the space on the breadboard, so I don't want to waste it. And yeah, that is everything. And this is our wire to connect to the power. I'm gonna check on my stream a bit before we can actually start it. And the stripper wire is going to put a little piece of wood in here, because I tried to use it before the stream, and somehow I actually accidentally closed this thing, and it always lock like this, and it doesn't automatically open again. So we're gonna put this thing in there, so now we cannot lock it anymore. So that's great. And I also got a few more useful component. This potentiometer, which is the replacement for the old one. You cannot use the old one, it's bad, it's trash. And I got a dip switch that we're going to use for our RAM. Different LED. I use this one because it used less power and it doesn't flash the entire audience. And I got a 100k resistor, ohm resistor, and I also got a bigger capacitor, which is 10. The last one we used last time is 0.1 microfarad, and this one is 10 microfarad, so hopefully it's better. So yep, I'm not going to actually build it now. Organize everything. This is our digital trash bin. Yeah. So make sure you can hear me. Alright. this. Where's our thing? The thing. Call my own stream. Is it actually something or something? Doesn't look good. It's like keep flash like blinking the cam. The top view. Remove this. Also need to remove this. Yep. And I'm going to use one of it maybe. Use only one of it because I try to like. What I'm thinking is that this potentiometer is, when we plugged it in, it looked like this, and it's very hard to adjust it. Maybe we can just bend it a bit. Ways up. And use it somewhere around here. Yeah, so if we use this thing here, it's going to like block our potentiometer from going like this. So let's try put everything together, because I want this chunks of breadboard to hold all the components for the clock. So we're gonna have two 555 timer. One is for the blink and the Astable Multivibrator, and the other one is for the debound circuit. And we have a 2-board chip, which is AND and inverter, in order to connect those two thingy together, and some additional component like a functionality. We're going to connect this timer, and we're going to take out the potentiometer for now. We need to find an inverter gate. I put this into the so it prevents from static discharge, static electricity. This is the flip-flop, this is the AND gate. And this is the inverter. So let's take it out. Oh sheesh. So this AND gate, let's search it up how to, what is connected. CN CD actually 74. What AC 08. So this is the VCC over here, and this is the ground. We don't care about it that much. Put it somewhere. For the AND gate, let's take out the inverter. And high static electricity. it's in. Oh, the other way around. Yep, perfect. We have additional like space over here. Maybe I can put LED and for the output. For now, I'm gonna do this a bit. Do this. LED. Put it this way. So I want the output going like right here. And yeah, I've got 1K resistor connect the LED to the ground. Seems so clean right now. Yep, so we'll cut the LED legs of the LED, make it shorter. Done. And also the resistor. Not too sure. And about our potentiometer, we can either move all of this close together so that we can have like a bit of the space for our potentiometer, but we can just use it on any of this gate because some of the input we don't actually use it. I kind of want it to make it better than this. Here. And here. Is it enough? Maybe. Oh, it's not enough. Have to move a bit more. Oh no, I break the legs. I don't think we can do this, so let's just put it on the gate. Make things space out evenly. Share the stream. There's someone watching. Share. kind of kidding me. Damn, what the hell. It's gonna put link in there. So that's small. Continue our stuff. Where are we? Yeah, potentiometer. And then so many stuff right now. Let's go with this first. So I want to connect the AND gate. Which one is the AND gate anyway? So this is the CD. So this one. Let me check my stream so you can see that this one is the AND gate. This one is the inverter. So can use the upper input to connect to the inverter to the LED, but I want to use the potentiometer up here, so we're not use the upper input anymore. And we're gonna check that data sheet is 5 volt is the first pin, so we're gonna move it a bit, try not to connect to the first pin. First input, second input, and the output. So there might be some problem here because the first will have to connect. So the output going to be something weird. How are we going to solve this? If you use it with the inverter instead, so let's assume that this is the input, the output. Input, output. Yeah, let's use it with the inverter. And we need some space for our button. Oh. Squish everything together anyway. Doesn't matter what. So we squish it in because let's grab one of it. I also want to use this switch to switch between manual and automatic blink, let's say that. So this button is, oh man, the leg is too small. Let me check it out. It's very short, like right this much. When we try to plug it in, kinda perfect with the size, but it's small, it's not stuck in there, so it just drop out. Let me try this maybe. It's not hot. again, maybe not, probably not. So let's just put it like that, and maybe we can use some glue to glue it up, because this is not good. This is not good. How are we going to solve this? It's not stuck in there. Try something. Can use one of these legs. These some of the pre-cut. It's not much. I'm so weird right now. Yeah, I can use it maybe. Going to use the button, maybe like this. Oh, perfect. So we have button and the switch, the right spot. Have a bit more of the space over here, but not sure I can use it. Haven't tested with the circuit yet. Maybe there's some problem, but right now let's just try to put everything together. Why is it not stick? It's not working this way, so let's use glue or something. But for now, let's try with the potentiometer. Try to make the LED blink. So connect everything up. Let's use the first, maybe the second one. The first one is close to the button, so I don't want to make it far apart. So we're gonna connect it with the 5V, and that is the problem because right now we don't have the top part, and use a longer wire. Not a problem. Extra wire in there. I bought this wire, I thought it's like single conductor inside, and it's not, it's multiple wire, which is still a scam, and it is very hard to use it this way. Maybe this is in. Go to the VCC. Boom. And what is our circuit? Kind of broken over here. I don't see anything, but we connect 1K resistor to the discharge. Let's look it up. Yep, so we're gonna connect the 1K resistor to the discharge from 5 volts, so kind of close there. Cut this off. Put it like this. And then we have a 100K resistor connected to the threshold, but we don't use 100K. I already got it here, but let's try use it now. Let us try 100K from the 1K resistor to threshold. You can connect it from here. Hopefully nothing go wrong. And we need control voltage, but we don't do it for now. Let's do something else. We have a capacitor from trigger, which we're going to use this one. Cut it a bit shorter, connect it to the ground, and I ruin it because it's supposed to be a bit longer. Maybe that's fine. Yep, it's fine. It's not fine, it's get a job done. We connect it with the trigger, and we connect it from 1K resistor to the which one? To the trigger. Let's try connect it from here. To charge this capacitor. I kind of want to explain it how this thing works again, but maybe not. Last time I tried to explain it, but chaotic. Comment. Can't hear anything, so let's connect this. I cannot see if it works or not. Not yet. Because LED is over here. I'm gonna want to jump the wire. Let's try to jump the wire a bit. Connect it from the output to the is it blinking? I don't think it's blinking, it's not blinking, so something wrong with our circuit. Connect this to the ground. Yeah, and we forgot to connect our chip to the ground. So we need a smaller wire. Disconnect the capacitor for now. It's so hard to see. Do it again. it's blinking. Yeah. Drink water. So I think this is fine. Oh man, we can just use this clock to control the computer, but it's very slow. You can see it's a, so we can use the potentiometer to like change the variable of this resistor 100k over here. So instead of using the 100k resistor, we can use the potentiometer so that we can make it faster or slower. So that is the idea why I bought the potentiometer. I'm gonna disconnect the power so that it doesn't short the circuit. Let's connect everything with the potentiometer. So I need a wire that can do that. I'm not going to use the jumper wire because it's not a testing. I'm going to stop there. So where's my, yeah, it is here. Let's use maybe white to organize, to easily organize the thing. So hard to just cut it off. Let's take it out. So we're gonna cut it like this. Yeah. Sheesh. And measure it around here. Maybe, probably not. Cut it out. This is how you do it. Oh, it's not focus. Please, yep, sir. And move it down. Gonna get to this thing. Hopefully it doesn't interfere with the how do I say it, with the inverter chip. This to the bottom. Yep. And the other side of potentiometer going to connect to the ground, so we're going to use the black wire. Let's see the representation for the ground. Right. Let's connect to the ground. And we need one input back from the potentiometer. I'm going to use this color. Kind of random though, it's not really. Maybe I need this to be a little bit more, a little longer. It's not really long, it's still short. so hard to just put it in. Yep. And we put it into this, maybe. Yep. Why this wire is so hard to connect? Yeah, now it's in. This side is not in. Yep, it is in. So we migrate it and use the potentiometer instead. Now let's connect it again. Sorry, I'm having a bit of cold. So it doesn't seem like it blink. Maybe it's too fast or something. But let's adjust it. And it's still not. So what's the problem here? So maybe we connect the potentiometer the wrong side. I need a longer wire to connect. Let's test it with the jumper wire first. Maybe it has specific ground and not ground, but I'm pretty sure that the middle one is the output of the potentiometer. I don't know why the cameras keep blinking. So it's not working. Maybe it is because the inverter chip, let's disconnect it. Get the chip out. Now we gotta get the chip out and try to do it again. Oh, so the problem is with the inverter, so we screwed. We cannot use inverter anymore. Going to be a very big problem if we try to use the inverter. So as you can see, if I adjust it, I can make it very slow or very fast, because this resistor limit how the current flow into our capacitor. So if we make it big enough, the current flow slow. I don't know how to say it. It's not slow. Electricity go with the specific speed. It doesn't matter. So maybe it go like less current to the capacitor, so it take more time to charge the capacitor. So the cycle go differently. So our problem now is that we cannot use the inverter chip, because if we use it, the output is not right, and we don't have anywhere else to put the potentiometer. Maybe I can try to use one of my trusty breadboard. I bring it from home, which is very small. Yeah, let's try use it. Disconnect the power and rearrange everything on the board. the potentiometer going to be somewhere. Oh, this thing is not connect with our breadboard, so they are completely different. How are we going to do this? Is the other? Alright, we can connect it like this, so we can put it here maybe. Try to get the, yep, so can put it like this, but that is not the way I want it. Oh sheesh. Oh man. Let's break something. Why is not in? Holy sheesh. I put it down here, but I cannot put it up there for some reason. Yep, now it's in. It's in. Hopefully it didn't do anything wrong. So let's switch potentiometer, put it here maybe. Let's not do that yet because I want to put this thing back on. And now our power and anything else, we won't have any problem with that anymore. Let disconnect everything for now. And rearrange our board again. What a move, what a... And we can maybe use the button on this board too. Yep. And maybe this thing, maybe not, because this thing is, it's more like better connection with this board, the switch. potentiometer. So we gotta supply the potentiometer from this 1K here. Perfect. Seem smooth. Connect this to ground, but I'm not sure how to do it yet. Maybe you can just put it directly to the ground over here. Very short one. Remove some of the wire from it. That's great. Oh, you just dropped it. The switch. Why is it so hard to just connect it in? Now it is in. Oh man. Connect this to the ground. Yep. And our capacitor. Yep. And the output. Which way? Put it like this for now, and maybe a couple of jumper wire. Okay, resistor. And we have to connect both of this thing. Power up. Test it out. Something not working. I connect the LED the wrong way. Alright, let me check my stream so we can see. Yep. So it's blinking. Yes, sir. And the problem with this breadboard is that I removed the sticker, which actually isolate this button part from anything under it. But I bad enough to not realize it. Maybe we can use some tape to tape it up. But for now, let's not care about it that much. So disconnect everything and start working with our put LED away. Let's start working with the D-bound circuit. Where's the 555 chip? You can just put it here. I don't want it to be too close because this thing can put it here. Here. So yeah, I can just put it somewhere right here. Gotta connect it to the power. I want to use this. Clean everything up. In my face. Right, where are we? So we gotta connect everything to the power and the ground. Put everything over, and this thing, gonna put it here first. Just gonna push it to the ground. too hard is to connect it, put the wire in. Disconnect it. How long has it been? An hour, just to try to put this wire into the hole. What a day. I like to spend my weekend put the wire into the hole, reinventing the wheel. I'm not sure you can hear me perfectly or not, so I'm gonna try to speak louder because the microphone is up here, it's not down here. Right, it's in. It is in. And just use one of this. I don't want to. Maybe I want to cut the wire again because I don't want to use the longer, really useless, like waste the wire. This to the power. Yep, it's in. Now let me check out my circuit I designed before, because I don't want to redesign it again. No further. So it is here. I throw it on the paper. So basically we gotta connect the 5 volt to VCC. That is done. We connect 1K resistor to trigger. So 1K resistor to trigger. So we can just plug it from down here. Oh sheesh. To trigger, and also that same 1K resistor connect to the button to the ground. And our button is over there, quite far from here. Just put it here. But I put a button here instead. Let's put it somewhere here. The connection is not perfect somehow. Doesn't sound perfect. Straight it up. Yes. Can I get to the ground? One of it to the ground, so to use a different one. Yep, to the ground. And we need a better wire. Connect it to the button. I don't know why it keeps blinking. So destructive. What am I gonna see? Yep, it's in. And the wire is not far enough. What a day. Redo it. Maybe this one is perfect. No, it's not perfect. What a damn day. Still not there. What the hell? I'm gonna redo it again. What is that going on over there? Let's do it this time. Make it perfect this way. Yep, it's in. What else? And then one bigger than 1K resistor to, so we may want it to be slow or fast, maybe. That is 100K resistor that connected to the discharge and the threshold at the same time. So discharge and threshold. So we're gonna connect it from here. Where is it? Yep. Put this thing down here instead. So it's discharge and threshold, which is this one. that to the threshold. Many centuries ago. This. Yep. And also that thing we have to connect to the capacitor to the ground. I'm gonna use this capacitor. Connect it to the ground. Make it too short again, but yep, never mind. It's good. To the ground, and everything is fine. So we gotta connect it to the LED to test it out. Let's put the LED here and get some wire. Connect the output to the LED. What is our LED state? Boom. So connect this together. And our power. Why? Damn, what is wrong with this again? Maybe our button is. Oh, okay. I know what's wrong. The schematic of our button is wrong. Yep. Alright, let me check my screen so you can see. Click it, pop it like that. We cannot just use a button to control our computer, because inside, as I explained it, there is a mechanic, a spring, something like that. So it's not reliable, because if we click it, sometimes it could like bump and it produce multiple signal. So we gotta do this so that our signal is a bit long, but it's like it's only one going in. So for example, if I try to bound it with my own hand, bound it, just one, it doesn't do anything. Yep, so everything is working. We're gonna connect these two circuit together. Work a very similar way to the Astable Multivibrator, but it just not vibrate. It just wait for the input from our button. So I think the way it worked, I designed it last time. So if I click it, the charge from our capacitors, maybe it's run to the ground, all of it, maybe something like that. I forgot. Just need to reanalyze the thing. But now let's connect it together. Let's find the AND gate. This is, I think this is the AND gate. So it's CD something. Here, connect it to the ground so it get wired. which one is ground, so this one. Ground, and we need power, 5 volt. I never used AND gate before, but hopefully it's very simple as other chip, nothing complicated about it, hopefully. Maybe we don't need a resistor or something for that. Yeah, now the chip is power up, or drop my mouse. So we have input and output, but I'm not sure which one I'm going to use, so let's see which one is the closest to. So this is A and B. So let's use the bottom. This is the output and this is the 2 input. So different wire, connect it. Here, let's connect it from there. Yep. The first input. Is the output from this one. So I want to use like AND gate. So what? So how are we going to do this? Let's find a pen and pencil or something. Which one is the best? So here's a pen. So our output is like this. Let's say this is the D bound, call it B, and this is the Astable Multivibrator, that call it A. What a name, so perfect. So we want only one of this going to come out. Like we have to select which one are we going to choose. Like are we going to want the vibrating circuit? So if you want to, oh my uncle, so we have a switch. So our switch is right here. So we're going to use this switch to turn on and off which one we're going to use. So but so if this switch on, we can choose the oscillator or something. So we can use the AND gate like this and connect this with the switch. Let's say this is the switch, and our B also use the AND gate, but we have to invert the output from this one, so it look like this. So we have to connect our switch first. Gonna put it somewhere right here. The problem is it is not like stuck there. It's very wiggle. So I have to connect it to the power, but I cannot. So let's put it here. connect it with the power. In. Now we have to use the inverter to invert the input. Let's find get good at this. Maybe the inverter is working the same way as the AND gate. The wire is too much. It's too many wire. Remove some of it. Why so hard? Do we need an engineering degree to do this? To connect the wire? Oh man. Oh jeez. That's gonna break it. Ruin the entire thing. Do everything. Start from here. Move it.
Chân phật cà phê oi Yun chân phật oi.
So I'm gonna check out what chip is this. So it is SN74 Xeon. Yeah, but it's this one. Which am I string is it? Still perfect, yep. So ground and VCC. Perfect. it. The output and from the why so far from there. Let's try with the this one. What is it? So this one is the debound circuit. So we're gonna turn. So yep. What am I talking about? Wait, I think we can do this first. We can put the output from our switch. Can put it here, somewhere near the circuit, so that we don't have to jump very far. So right here. Now we got two input in, we got one input out, so we can connect this input together, but not yet. And then we have to invert the switch, so it have to go through the inverter, one of this, maybe the last one on top right, top right, yep. Use the top right. I'm gonna invert it first. Here, after inverted, we have to take the output and feed it into our AND gate, so we can use a different color. Wait, oh, the input is not there, the input is, God, wrong one. Live stream. saw the output from the inverter.
Dạ, bạn đừng thêm con mình. Dạ. Bạn tự biết ba từ chụp từ cả.
Connect it to the input of the second gate. I'm gonna check the second gate. Yep. Oh, so bizarre. We should have connected better than this. This is not right. And then we need the output from our Astable Oscillator Multivibrator. And then we take out one wire. So make our life more. Now we got we can connect the output together. Where's second output? Leave it there. And here. I dropped that switch again. What is going on? This switch is not good. Now we have to take that output, put it somewhere. Maybe we can use it to invert again. We need the inverted output somehow in the future. Not now. We put the output up here. Connect it to the ground. Put the final wire. Wait, we can just use resistor from this. Yep, connect it with the ground, and we need the output from thingy. Put it right here. Yep, right here. Now the output is done. So if you want to connect it to something else, go here. So you want to connect to something else, we connect to the last one over here. Connect it to the power. Okay, so it light up because we turned this on, which means we're going to use the debound circuit. Now I turn it off. Now it's switched back to the oscillating circuit, but the output is so low somehow. The output is very low. Something wrong. Now we turn back on to use the debound circuit. Now we can use the button instead of a potentiometer. Alright, we need the halt, which basically an input that tell our clock to stop, but I don't think we're going to do it now. Let's do the halt later. And let's connect the ground and 5V across the board. The problem is everything is already crossing the board. We have to organize this in a better way. And the ground. Now let's power it up again. Not working. Something went wrong. Oh, I forgot the output. Right, now it's the blink. Wait, there's something wrong when I try to use the... It's also working with this. Maybe the AND gate is not working properly. I can use it this way. When I tried to do this, the AND gate is the LED just blinking a bit faster. That make it slow enough. Not sure what's going on, but something with the hardware. Yeah, all of this is just the hardware. But I'm not sure why the LED is like very low. What is this? I think this chip is made up of like this type of it, which is CMOS, and T something is transistor based, and the other one is MOSFET based, which is make a difference because one of it is drive current and the other one is drive how do I say it? The other one is drive voltage instead of current. But I think we're done with the clock. Gotta clean everything up. Take this string, a bunch of garbage on the table. Gonna need glue to glue the switch. That's either way it's going to drop out, going to fall off from the board. I don't know why the camera is keep blinking. It's disturbing. How long is it? Only an hour or something, so we can go with the memory resistor. So this is our clock. Let's try it one more time. Very cool to see it working. So it's blinking faster, slower, and I can switch the mode. Now it's off, but I can turn it on. I don't know why it's so low. Let's try a different LED. Try this one. Camera kept blinking. Oh, this one's also low. It's supposed to be much brighter. Try to lift it up. There's something wrong with the connection. So one thing about it is that we don't need to lift it up, and the chip is burning. Now let's move this thing a bit up. We're gonna use it soon, maybe. Now let's work with our resistor. I'm gonna move this way. Redo all of this. I just realized that we don't need resistor for the chip to work with LED. my switch. So this is the flip-flop, hopefully 4-bit. This is another 4-bit flip-flop, and this is an inverter. So I kind of want to make, wait, move everything. Sheesh. Move everything. Garbage. Here's my breadboard. I want to use this again because it's going to be very difficult to try to use only the upper side. And the trick is that to save all of this is we can use multiple board with share power line like this. So we have two, and this one only have one, so we don't have, we save one of it, which is in here. Put it back, and let's do this for now. So let connect the LED again. The LED is very annoying. Mix it up. So 2, 3, 4, 5, 6, 7, 8. Or like cut it off. Already too late. Now let's connect it to the board this way. I'll connect it this way because we don't use a resistor, so we can just put it directly to the ground, so we can see what's inside our RAM. A resistor, not RAM. RAM are different. So connect it this way. Get this chip again. maybe leave a bit of space for the wire to go through. But do we need other things here? So first of all, we're gonna need this thing for sure, which is dip switch. Remove it. So let's put the dip switch this way. It's very loosely connected. It's not good. Find something to use another one of this. What is this? Oh, it's a AT Mega, which is a microcontroller from Arduino Uno. Yeah, this is more better, but I don't want to use this thing at all. How do we connect this properly? Oh, why it's so small? I just put it here and connect it. I just throw a bunch of it. This thing, this small piece of metal, is going to be very useful. So we have to connect all of this pin down here together. Wrong. This. Good, we need one more. Yep, now it's perfect. But this thing's still not going in properly. Oh no, I don't know what to do with it. Maybe order a better one, but I already ordered like 4 of it. Oh, that's why they are so cheap. You can solder it. I don't have the soldering iron. So let's connect this with the power. Okay, what are we doing anyway? So if we put this, we can change the address, but we need the input. This is only for the we don't need address because it register, so we don't need address. Mode carries. So this is the input. Why do I make it so close? Let's not make it so close. Too close. Put it right here. And we also need a bunch of input, which is enable input, enable output, something like that. So we're gonna move it a bit further. Check out the chat. No one sleeping. Yo, I cannot. Unaware. So let's see what we can do next. So this is, where's the chip? It is CD. No, that is CD24HC. 173. So here it is. We have to invert the input of a let's put it into the inverter first. One of this. Still have to connect everything to the ground and power, so let's do that first. Put this thing. I ruined it again. 2 and the other one. So like this. Also dark. Now it's done. Let's connect the input for how many input are there? Output resistor, output enabler and input enabler, and we don't care about the reset. Just keep it there. And we have clock, which is here. Let make our reset go to ground because we don't want it to be enabled. That's it. So reset is for next to VCC. Reset ground. Nope. I didn't need it. So easy. What a life. Ground. Now it's ground. The clock pulse, not sure yet, but we have to connect the input enabler and the output. Make it close together first. Use white and yellow. And it's very short one. So here's the output enabler. Yep. So clean. the second chip. In case you don't know, one of these chips is only 4-bit, so you have to use 2 of it. Let's get out the yellow, which is for the input level. To connect it together, all of it, like across the chip. So we're gonna need somewhere around why it's not going. Also the output enable. Boom, done. Oh my back. There. Coming back. We have to connect all of it to the inverter. So this can use the top one. Cut this thing out first. Why it's so long? Why did I make it so long? And the second output of the inverter. Now inverter going to go somewhere around here for the, what is it again? Enable input. Right here. It's hurt, my fingers hurting. Hurting my finger. Like this. And then the white one. So also have to connect to this. This much. Got it wrong maybe. Here, yep. To the output. Like this, maybe. Check camera. Yep. And now this thing is done. The only thing left is the input and output. And I already forgot which one is the input and output. So Q. It doesn't tell here. Let us zoom. Last time we used D as the output. No, not D, so it's going to be Q. So we have to connect this Q to here. So let's use a different color. And we also have the clock pulse, so let's find a different color for the clock pulse. And we have to connect all the clock pulse together. this switch is annoying. Alright, clock pole. Everything seems flat. Seems alright. And we have to connect them with the knob. Yep. Solving stuff. Maybe stop shaking up. So this is the first output. To do this a bunch more. Q2. short. Oh no, it's fine. This one's dead. It's a fart over here. My hand's shaking so much. So much better. Only two more.
Chà ơi.
It doesn't stick well, so I'm gonna need a different one. Oh, too short again. last one. Oh god, done. This is the output. Now we have to connect the input with this switch over here, the unknown switch. Change the color.
Mũi tức này mơ sọ các bạn là toàn mũi tức kìa đây mũi tức thật em lấy điện mình tay mũi tức này
Ôi giời.
là cho cả sạc đây kìa sạc mũi tức ở đây.
So I can put it like this, and we have a line up here which we can connect with from the bus instead of dip switch. But can we have like two options to use dip switch or the bus instead? Eight of this. Now let's do 3 of this first. Almost too short. Yeah, it's kind of too short. It's not almost, so need a bit of take this off. Why so loud?
Chốc nè, ai mới nè ná vô lo trên cái trên chặt cháu là rồi rụng mà ơi à sao ơi à ai cứ lo bạn mới rồi chơi nè
There. I'm making resistor is so hard.
một xả rối à này
Difficult. This 4 down.
muốn xài thơ ấy nhá
Computer.
thơ công tơ
Bah.
thấy không chơi thơ à nhé sao chơi thơ này mà một chân con nha cho mình tính là ta pha này cho mình tính là chăm mà lên tiền rồi lên mình tính là pro từ cho mình tính lên
dip switch to power. Put it on here. The dip switch is not connected. So we put it out first, and let's see. This. We need these two. And we need one more wire for the clock poles. So our clock pole is here from the clock itself, and it's here. And we're going to have input and output enable. The bottom one is output enable. So it's the bottom is the output enable. So we have to put it high, maybe. And the input enable is low. Put it low first. Let's put it like this. And we have to connect the power from to the clock. I mean, to the clock. Clean everything up. Clock up here. And let power up. Maybe it's going to work or not. It's not working. So what's the problem again? Let's try the clock. So the clock is the push quite a bit low. Oh, damn. Why it's high? So output enable is high. Let disable the output. Okay, that's working. So let's input enable. Put it high and push the clock. Why does this value over here? Why the clock like that? Something wrong with the clock. Let's check the clock out first. This is the clock poles. Put it here. The clock seems to be very bad condition. Alright, so it's blinking. what I'm going to do is
Bạn tới cái lại thử cam đấy thôi. Bạn tới sai như thế thôi.
I kind of want to invert the input and then re-invert it again so that we
Mình chắc
can
cái nữa.
get multi.
Phát time như mình tự.
Maybe we can get a
Thành nữa
higher.
nè. Nè, vào thành nè. Đấy. Vào họ mình tự á. Okay.
So we put it here to invert it. Now we get the inverter. Wait, is it the inverter? Yes, it is the inverter. Like a different yellow one. Oh, sheesh. I ruined it again. Shaking. Holy sheesh. Inverter, and now the output from the inverter. Should go here to here. Power it up. Oh yeah, a bit higher. That's better. Alright, let's connect it again to our chip, to our module, not chip anymore. So the clock should go right. Let's. Oh man, what's going on? Why this? All of this is high. Oh, I know. Should we connect it to the ground so that it? Oh, we should connect it to the ground. Because there's some like error in not working, so maybe we can use this jumper wire. Four more. Right now it's 0. You can put it on 1. Doesn't work. That work. That work. Accept this chip. So let's try something different. Disconnect everything. Put it here. Put this. Put it high, it's still not working. So maybe the output is not working. What's happening? This thing. You don't need to push the clock. So there's got a big problem with the output pin. So let me move the output. And use this instead. I need to order some of this more. Disconnect the power so it doesn't burn your chip. this? Why doesn't work with this? Something. Let's try different LED. Maybe it's because the LED. Yeah, it's the LED. So somehow it's not working. Need 3. The chip is fine, except the LED itself. Oh, I put it wrong. Polarity. Yep. What the hell? What's wrong with me? That's why it's not working. Yep, everything's fine. If I were to switch it, boom. Boom. Now it's stored the value 000111110. The dip switch is bad. Let's try the dip switch again. Let's try it again. Now just blink with the clock because the input is not stable. And it's still not stable. So we have to like drain all the value from here to the ground somehow, but if we drain it, it's going to be some problem. I'm not sure what's the problem there. So this one on. One on, and I put everything. So we need a different type of switch. How are we going to drain this to the ground? Let's not think about it yet, because everything seems fine. Let's turn the switch up and put it. So the switch is not on, the switch is bad. Disconnect the clock. What is this? It's kind of great if you use jumper wire, but it's very messy. Disconnect the clock, enable power, put the clock away, and cross voltage. Disconnect everything. Now let's use this wire instead. Again, let's sort it by length. water is even shorter, shorter, shorter. And this one is longer. And this is about right here. And this. Okay. So let's use this. Make this one. How do I stop? How's it stuck in? I can just use the long wire instead. Is that right? Because space is different. That. shorten block. Because we cannot use the dip switch right now. Put it too low. Clock. And this thing, I'll put all of it to high. Yep. Now let power it up. And then power across the board. Here, power the clock. Power up the clock. Right. Everything seems fine. What is going on again? Well, the LED is not light up. As we can see. reverse polarity. Hopefully I didn't burn anything. Alright, I didn't burn anything. The wire is hot. That's why I need to use a different color. This is not good. Just reverse it. Boom. But everything is fine. One. Boom. So for example, if I want to like manually push the clock, I can just set everything back to like 1 0 0 0 1 0, all 0, so I can just push it. Done. I can just change this to output enable or not, depend on a thing. Push. Yes, so it's working. Let me make this thing very slow. And just change this and can wait for the clock. Boom. Alright, so our resistor is working, but the wire is bad. It's so annoying, and we cannot use a dip switch. Dip switch is bad. So how are we going to like drain the voltage? Let's try draining the voltage to the ground. Test something. What is this? Let's test my theory. I'm gonna put everything on the same trail. And this thing will run through 100k resistor to the ground, to the actual ground. This is not a ground, so the actual ground is over there. So everything should be 0, like no error. So if I don't do that, let me make it faster. Yes, so it constantly change to 0 back and forth. So if we have to drain it out. Now everything is 0. So maybe we can use the dip switch right here. Everything's on. But the problem is everything is connected together. So we cannot, if one on, every other one is also on. So let's try a different theory. Let's put the 100k resistor. Let's disable this first. For each one of these to the ground instead. Each one. This. Let's just use kind of. high, so we have to use one of three. Drain. Put the dip switch. Ooh. Turn this. The last one is not good enough connection. I'll find something to switch this. That fire pen. Yeah, this is a pen. Yes, it's on. I should have bought a 4-bit dip switch instead of this one. What a regret. So we can use this circuit over here to drain everything to the ground. Everything's working and our resistor is fine. Wait, why? Too late, just disconnect it. Disconnect the power. Back to our trusty thingy. Clock signal. So this is our resistor. We have to connect this wire using a hookup wire instead of this jumper wire. So I'll do it later. Maybe put it there so that I don't forget about it. Maybe I'll forget about it and then everything stop working. I don't know why. Just put it there. So that is our stuff. And we're gonna connect it together. Like this, maybe. Yeah, two different type of breadboard, but yeah. So maybe next stream we're going to talk about SRAM, and I'm gonna try to rewire this thing a bit so that it doesn't. So it's very thick right now. So yep. So I saw the dip switch. This one is also bad. It's very small legs. It's right there. So we build clock and a resistor. We need a few more for A resistor, B resistor. Let's check out the schematic, the architecture. Oh sheesh. Close it. Where is it? So here it is. We have a memory address register, we have A and B. Maybe we need a few more for the ALU, and we have the output register. We have the sub op register, we have op register. So we need a lot of this register. I don't know how can we build it in a different way so that we don't have to connect all of this wire like that. But it's kind of fun if we have this wire pre-cut. Put everything here. So my hand. Close this. So that's everything for now. I'm gonna end the stream. I'm gonna have some lunch, and I'll see you guys tomorrow or not. I don't know.